Let's solve some problems. Let's say x4 minus 4x cube plus 3x squared plus 4x minus 4 equal to 0. Okay, now here, remember the idea, Ferrari's method idea is to come out with perfect squares on both sides of a equality so that we can arrive at difference of squares. So let's take these two and convert it into perfect squares. So x square square minus is there, so minus 2ab. So 2 will be there. Let us say x square is this a, and we have to arrive at b, and that itself will become the square here. Okay, so what additional thing that we require to make it as minus 4x cube? We require 2x. Yes, that 2x we make it as a square. Now remember, we have added this additional term, so we need to subtract it to maintain consistency. So 2x square is equal to, now let's bring these three on the other side, minus 3x square minus 4x plus 4. Okay, now this from here to here can be written as a perfect square. X square minus 2x the whole square is equal to, now this minus 2x the whole square can be taken to the other side. So 4x square minus 3x square minus 4x plus 4, which is equal to x square minus 4x plus 4, which luckily for us is a perfect square. Now let's bring it both to the same side. X square minus 2x the whole square minus x minus 2 the whole square equal to 0. A square minus b square gives us x square minus 2x a plus b. So plus x minus 2 times a minus b. So that is x square minus 2x minus x plus 2 equal to 0. Now don't again multiply it. Simplify it here itself within the bracket. So this becomes x square minus x minus 2 and x square minus 3x plus 2 equal to 0. Now we know that if this has to be 0, then even if one of them is 0, then it will be 0. So minus 3x plus 2 equal to 0. That means we have got two quadratic equations. We solve each of them. So this becomes, let's see whether we can do this. X square, easy to convert minus into plus, so minus minus. Now what do we do? Let's say 2, let's say 1. 2 ones 2, minus into minus plus. So if we make this as plus, what do we get? Minus 2 plus 1 is minus 1. So which means x is equal to minus 1, 2. Okay, what about here? Again, x equal to 0, minus minus, and here 2 ones 2, no, 3 ones 3, no, 2 ones 2, so 2 ones, 2 plus 1 3, 2 ones 2. Now the sign matches, so minus into minus plus, minus minus minus. Okay, so this means x is equal to 1 and 2. So therefore x is equal to minus 1, 1 and 2 is, now remember in this particular case we ended up with a very straightforward, we ended up with perfect squares on both the sides, but usually that may not be what is happening, in which case we will end up with cubics and quadratics. So let's see the next problem. X4 minus 12x cube plus 41x square minus 18x minus 72 equal to 0. Okay, again let's take these two x square square minus 2x square and this box plus whatever comes here inside that box becomes a perfect square here, a square here. So what do we multiply it with to get minus 12x cube? We do 6x, right? 6 to 12, x cube. So that 6x, we square it here. And since we added that term, we subtract it as well. And these we take it to the other side. So minus 41x square plus 18x plus 70. Okay. So now this can be written as x square minus 6x the whole square. This 6x square, 6x the whole square goes to the other side, becomes plus. So 36x square minus 41x square plus 18x plus 72. This becomes minus 5x square plus 18x plus 72. Okay. Now what we'll do is we will add a term here, x square minus 6x plus lambda the whole square. And by adding lambda, we have added some additional terms. So we have to remove them. So minus lambda square minus 2 times x square minus 6x lambda is equal to minus 5x square plus 18x plus 70. And then we take this to the other side. So minus 6x plus lambda the whole square is equal to lambda square plus 2x square minus 6x lambda minus 5x square plus 18x plus 72. Yes. Now let's group them. Okay, let's first open up this bracket. So lambda square plus 2x square minus 12x lambda x square lambda minus 5x square plus 18x plus 72. Okay, let's group them based on x. We get 2 lambda minus 5x square. Then let's look at x. So x is there here and x is there here. So plus 18 minus 12 lambda x. Okay. And whatever is remaining. Remaining is plus lambda square plus 70. Okay. So we have got a quadratic in x. Now for it to be a perfect square, delta has to be equal to 0. So therefore, let's evaluate delta and make it equal to 0. So b square 18 minus 12 lambda square minus 4ac 4 times 2 lambda minus 5 c is lambda square plus 72 equal to 0. Okay. Now let's open up these brackets. 18 square is 324 minus 2 times 18 times 12 is 432 lambda plus 144 lambda square minus 8 lambda minus 20 times lambda square plus 72 equal to 0. Now let's open up that bracket as well. So 324 minus 432 lambda plus 144 lambda square minus 8 lambda cube minus 20 lambda square plus 576 lambda minus 1440 equal to 0. Let's open up this bracket. 324 minus 432 lambda plus 144 lambda square minus 8 lambda cube plus 20 lambda square minus 576 lambda plus 1440 equal to 0. This implies, now if we simplify it, how do we simplify it? Let's divide the whole thing by 4. So 4 8s 32, 1, 4 1s 4, 4 0, 8 lambda plus 4 3s 12, 4 6 24 lambda square minus 2 lambda cube plus 5 lambda square minus 144 lambda plus 4 3s 12, 4 6 24, 360 equal to 0. Okay. So now let's again simplify it. Minus 2 lambda cube plus 36 plus 5, that is 41 lambda square minus 252 lambda plus 441 equal to 0. Okay, so we have got a cube. Okay, we can take this minus to the other side, take minus common out. So we end up with 2 lambda cube minus 41 lambda square plus 252 lambda minus 441 equal to 0. Okay, now we have ended up with a cubic equation. Now we need to solve this. How do we solve this? We can use any method. We can use Cardano's method or whatever method we feel comfortable with. We can use that. Let's look at something called as a rational root test. Right now, if you have an equation a naught x cube plus a1 x square plus a2 x plus a3 is equal to 0. All rational roots belong to p by q, right? Where p divides an. So if it is a cubic equation, a3. So depending on the degree of the equation, the appropriate coefficient will be divisible by p. Okay, and q divides a naught, right? So which means if we apply that principle to this, what do we get? Let's see. So in our problem here, we have the factors of an. That is, an is 441 is equal to 237. And factors of a naught, that is 2, is equal to 1. We have two sets, 2, 3, and 7. That is P. And we have Q, that is 1 and so the roots would be 2 by 1 plus or minus 2 by 1, 2 by 2, 3 by 1, 3 by 2, 7 by 1, 7 by, okay. So which means this is equal to 2, 1, 3, 3 by 2, 7, 7 by. So let's take the equation and substitute 1 by 1 these values. So we have 2y lambda cube minus 41 lambda square plus 252 lambda minus 441. Okay, equal to 0 is the equation. Now let's put in 1. So we get 2 minus 41 plus 252 minus 441. Okay, this is for 1. This is no, not possible. 2. So 2 times 2 cube is 8 minus 41, 2 square is 4 plus 252 times 2 minus 441 equal to 0. Now if you solve this, you will find it is not equal to 0. Now let's take 3. So 2 times 27 minus 41 times 9 plus 252 times 3 minus 441. And this, if you evaluate, you will find that it is equal to 0. So therefore, lambda is equal to, I'll be doing a separate session on this rational root test later. Okay, now that we have found lambda, let's go back to our original starting point. X square minus 6x plus 3. Remember, plus lambda was there. Now, okay, let me actually write that statement first and then we'll do the substitution. Square is equal to 2 lambda minus 5 x square plus 18 minus 12 lambda x plus lambda square plus 70. Now let's do the substitutions. We end up with 3 to 6 minus 1, 5. So x square. And here 12 is 36. 18 minus 36 is 18. So 18 x, then 3 square plus 9 plus 72, which is equal to x square minus 18x plus 81. And this is a perfect square. X minus 9 the whole square. X square minus 18x plus 81. Now let's bring that square to this side. So x square minus 6x. By the way, this lambda would be 3. So plus 3 the whole square minus x minus 9 square equal to 0. Okay. Now a square minus b square. So x square minus 6x plus 3 plus x minus 9 times x square minus 6x plus 3 minus x plus 9 equal to 0. Let's simplify this. X square minus 5x minus 6 equal to 0. And then here x square minus 7x plus 12 equal to 0. This can be factorized. X minus equal to 0. So this will be what? 616. So 6 ones. And here this will be plus. So minus 6 plus 1 is minus 5. Similarly, x equal to 0. Minus. 12. 6 to the 12. No, 3 4 square. 3 4. Minus. Okay. So x is equal to minus 1 6 and x is equal to 3, and therefore x is equal to minus 1 3 4 and 6. Okay, so these are the roots of the equation. Let's do the third problem. Okay, the third problem is x to the power of 4 minus 2x cube minus 5x square plus 10x minus 3 equal to 0. Again, let's take these two. X square minus 2x square and a box plus whatever is there in the box will come here and get squared. So what do we need? Minus 2x square is already there. So the only thing that is required is x. So that means here we will end up with x square. Now x square is what we are adding. So subtract is equal to 5x square minus 10x plus k. So this can be written as x square minus x the whole square is equal to this minus x square goes to the other side. So it becomes 6x square minus 10x plus k. Now what we need to do is make this into a 3 terms square. So x square minus x plus lambda square. That means we have added some additional terms. So we need to subtract it. Minus lambda square minus 2 times x square minus x lambda is equal to 6x square minus 10x plus k. Now let's take this to the other side. So we end up with lambda square plus 2 x square minus 2x lambda plus 6x square minus 10x plus k. Let's group them based on x. So we end up with, okay, let's say 2 lambda plus 6 is x square. Okay, now lambda is what else is there? Minus 10x. So let's have it as minus 2 lambda plus 10x, and we are left with plus lambda square plus. Okay, now we have got a quadratic. For it to be a perfect square, the discriminant has to be 0, which means b square, that is 2 lambda plus 10, that minus will become plus when we square it. So b square minus 4 times 2 lambda plus 6 times lambda square plus 3 equal to 0. Okay, let's blindly keep simplifying it. 4 lambda square plus 2 to 4 times 40 lambda plus 100 minus 8 lambda plus 24 times lambda square plus 3 equal to 0. This becomes 4 lambda square plus 40 lambda plus 100 minus 8 lambda cube. Let's keep minus out. Then we have 3 8 24 lambda plus 24 lambda square plus 72 is equal to 0. So this becomes 4 lambda square plus 40 lambda plus 100 minus 8 lambda cube minus 24 lambda plus minus 24 lambda square minus 72 equal to 0. Now let's see whether we can divide everything by 4. Yes. So lambda square plus 10 lambda plus 25 minus 2 lambda cube minus 8 lambda minus 4 6 lambda square minus 4 1s 4 4 8 32 equal to 0. Okay. So now let's rearrange them. Minus 2 lambda cube minus 5 lambda square. Then we have lambda 10 lambda minus 8 lambda. So this is not 8, this is 6. 4 6 24. I was dividing by 4. So minus plus 10 lambda minus 6 lambda is plus 4 lambda minus 6 lambda, no, minus plus 4 lambda 25 minus 18. So plus 7 equal to 0. Okay, let's take care of that minus in the beginning. So 2 lambda cube plus 5 lambda square minus 4 lambda minus 7 equal to 0. Again, let's put that rational test. Use the rational root test. What does it say? An is equal to minus 7. A naught is equal to A naught is equal to 2. So the factors of this are 1 and 2, and here the factors are 1 and 7. So the roots will be 1 by 1, 1 by 2, 7 by 1, 7 by 2. Okay. Now we need to substitute this and see. Remember, this is actually plus or minus. So if you put plus, what happens? If we take 1, it becomes 2 plus 5 minus 4 minus 7. 9, no. If we take minus 1, what happens? This becomes minus 2 plus 5 plus 4 minus 7. So we have minus 2 minus 7, 9, 5 plus 4, 9. So this is equal to 0. So lambda is equal to minus 1. Okay, now let's go back. So therefore, x square, we had this equation, minus x plus lambda the whole square is equal to 2 lambda plus 6 x square minus 2 lambda plus 10, not lambda, x plus lambda square plus 3. So since we have found lambda, let's do the substitutions. X square minus x minus 1, the whole square is equal to minus 2 plus 6 x square minus 2 plus 10 x plus 1 plus 3, which is equal to 6 minus 2 is 4. So 4x square minus 10 minus 2 is 8. So 8x plus 4. And this is a perfect square. So 2x minus 2 the whole square. Again, quickly confirm it. 2x squared is 4x squared. 2 2's 4, 2's 8 minus 8x plus 4. And we have x square minus x minus 1 square. Let's bring it to the same side. X square minus x minus 1 the whole square minus 2x minus 2 the whole square equal to 0. Why? A square minus b square. So x square minus x minus 1 plus 2x minus 2. This is a plus b. Then we have x square minus x minus 1 minus 2x plus 2. This is a minus b equal to 0. Simplified. Once you reach this stage, it's pretty straightforward. X square plus x minus 3. X square minus 3x plus 1 equal to 0. So x square plus x minus 3 equal to 0. X square minus 3x plus 1 equal to 0. Directly apply the quadratic formula. Minus 1 plus or minus b square minus 4ac divided by 2a. Here x is equal to minus b plus or minus b square minus 4ac. By this becomes, be careful about the signs. 4ac. So minus 4ac. So minus into minus plus. Okay, so minus 1 plus or minus root 13 by 2. And this is 3 plus or minus square root of 5 by. So we have the 4 roots of the equation. Let's do the fourth problem. Okay. So now the problem is 2x4 plus 6x cube minus 3x square plus 2 equal to 0. Now what we want to do is get rid of this a naught. Should be 1. So let x equal to y by 2. Yes, basically we are multiplying the roots by 2. So let's say 2y by 2 4 plus 6y by 2 cube minus 3y by 2 square plus 2 equal to 0. Now 2 times y4 by 2 2's 4 2's 8 to 16 plus 6y cube by 8 minus 3y square by 4 plus 2 equal to 0. So this becomes 2 8's. So y4 by 8, this becomes 2 3's, 2 4's. So plus 3 by 4 y cube minus 3 by 4 y square plus 2 equal to 0. Let's take the LCM and add them up. And that denominator 8 will disappear once we take it to the other side. So we'll be left with y4 plus 6y cube minus 6y square plus 16 equal to 0. Now let's do the perfect square. So y square plus 2y square and the box plus whatever you put here will come here. So now how do I get 6y cube? By putting a y, I get y cube. By putting a 3, I get a 6. Okay. So which means whatever is there in this box will get squared. Since I have added this, I need to subtract this as well. Is equal to 6y square minus 60. Okay. So this can be written as y square plus 3y the whole square is equal to, now this we take it to the other side, this becomes plus, so 15y square minus 60. Okay, now we need to add one more term here, so y square plus 3y plus lambda the whole square, and we are adding terms, so we need to subtract it. 2y square plus 3y lambda is equal to 15y square minus 60. Okay, let's take this to the other side. So this will become equal to lambda square minus 2. This minus will become plus y square plus 3y lambda plus 15y square minus 60. Let's open it up. So plus 2y lambda plus 6 lambda y plus 15y square minus 60, which is equal to, let's take y square. So this becomes 2 lambda plus 15 y square plus y. There is no other y, so 6 lambda y plus lambda square minus 60. Okay. Now this is a quadratic equation. If it has to be a perfect square, discriminant has to be 0. So which means b square. So 6 lambda square minus 4 times 2 lambda plus 15 times lambda square minus 16 equal to 36 lambda square minus 8 lambda plus 15 lambda square minus 16 equal to 0. No, this is not 15, this is plus 16. Now, this would imply 36 lambda square minus 8 lambda cube minus 128 lambda plus 60 lambda square minus 16, 6, 96, so 960 equal to 0, which implies 36 lambda square minus 8 lambda cube plus 128 lambda minus 60 lambda square plus 960 equal to 0, which implies 36 minus 60 is minus 24 lambda square minus 8 lambda cube plus 128 lambda plus 960 equal to 0. Now let's rearrange and multiply it by minus 1. So this becomes 8 lambda cube plus 24 lambda square minus 128 lambda plus 960. No, minus 960. Okay. Now 8, 1's 8, 8, 3 is 24, 8, 16 is 128, 120. So this can be divided by 8. So lambda cube plus 3 lambda square minus 16 lambda minus 120 equal to 0. Okay, we are going to reduce this equation by getting rid of the second term. The way we will do it is, we will say, let's say z is equal to lambda minus h. And here h would be equal to minus a1 by 3a naught, which is equal to, here 3 is actually n in general, the degree of the equation. So minus 3 by 3, 1, which is minus 1. So z will become lambda minus plus 1. So which means lambda would become z minus 1. Okay, so we will have z minus 1 cube plus 3 times z minus 1 square minus 16 times z minus 1 minus 120 equal to 0. Okay, let's expand it. We'll get z cube minus 3z square minus plus 3z minus 1 plus 3z square minus 6z plus 1 minus 16z plus 16 minus 120 equal to 0. Okay, let's expand it. So z cube minus 3z square plus 3z minus 1 plus 3 times z square minus 2z plus 1 minus 16z plus 16 minus 120 equal to 0. This would become z cube minus 3z square plus 3z minus 1 plus 3z square minus 6z plus 3 minus 16z plus 16 plus 120 equal to 0. This would become z square get cancelled. Second term is gone, so we are left with z cube. 3z minus 6z is minus 3z. Minus 3 minus 16 is 90, minus 19z. Minus 1 plus 3 is plus 2. Plus 2 plus 16 is plus 18. This is minus 120. Okay, so plus 18 minus 120 is minus 102 equal to 0. Okay, so we have got a cubic equation now. Again, what we'll do is we will use the rational root test. Okay, now what do we do? An, in this case, A3 is equal to 102 and A0 is equal to 1. Factors of 1 are 1. Factors of 102 are, let's do it below. So 102 factors are 102, 51, 34, 17, 6, 3, 2, and 1. 1's factors are 1. So therefore, we have plus or minus 102, 51, 34, 17, 6, 3, 2, 1. Okay, so now let's take from the lowest 1. 1 minus 19 minus 102. Very apparently it's not correct. What about minus 1? That would still not make a much of a difference. 2. Again, 19 to 34. Sorry, 19 to 38. No, not really. We need a minus. So 2 minus 2 will not work out. 3 again will not work out. So let's say minus 3. Minus 3. So this will become 19 times 3. No, it will not work out. What about 6? No, this will, minus will be up. So this has to become plus. So for this to become plus, minus. So minus 6, let's say. So minus 6 cube minus 19 times minus 6 minus 102. So what do we have? This becomes 636, 216 plus 114 minus 10. Does this work out? No. Let's see 6, because now this is coming big. So now this would become 216 plus, so minus 114 minus 102. So 104, 114, 102 is 216. 216 minus 216 is 0. So which means, sorry, not lambda, z is equal to 6. Okay. So since z is equal to 6, how will we figure out lambda? Remember, lambda is equal to z minus 1. So therefore, lambda is equal to 6 minus 1, 5. Now let's put in the value of lambda in our. So y square plus 3y plus 5 square is equal to. Okay, let me write the equation first, then we'll do the substitution. Okay, 15 plus 2 lambda y square plus 6 lambda y plus lambda square minus 60. Okay. So here lambda is 5. So 3y plus 5 square. 15 plus 5 to 10 y square plus 6 5 is 30 y plus 25 minus 16 is 9. This is 25y square plus 30y plus 9, which means this is 5y plus 3 the whole square. Now let's bring both to the same side. Y square plus 3y plus 5 square minus 5y plus 3 the whole square equal to 0. Y square plus 3y plus 5 minus 5y, no, plus 5y plus 3. Y square plus 3y plus 5 minus 5y minus 3 equal to 0. Y square plus 8y plus 8. Y square minus 2y plus 2 equal to 0. Which means y square plus 8y plus 8 equal to 0 and y square minus 2y plus 2 equal to 0. So y is equal to minus 8 plus or minus 64 minus 4ac, for it's 32 by 2a. Y is equal to minus minus plus 2 plus or minus 4 minus 4ac, 8. Right? So that means this is minus 4 plus or minus 64 minus 32 is 32. 32 is 16 twos. So 4 root 2 by 2, that is 2, which is equal to minus 4 plus or minus 2 root 2. Similarly, on this side, we have 1 plus or minus square root of minus 4 by 2, which is equal to 1 plus or minus 2y by 2, which is equal to 1 plus or minus. Okay, we want x, not y. So remember, in the beginning, we said let x is equal to y by, so therefore, x is equal to minus 4 plus or minus 2 root 2 by 2. So this becomes 2 2's 4 2 1's. So that becomes minus 2 plus or minus root 2. And on this side, it becomes x is equal to 1 plus or minus I by 2, which is equal to, actually I don't have to do anything. 1 by 2 plus or minus I by, that is equation solving using Ferrari's method. That's it for now. Bye.